This is Dr. Mir Mujibur Rahman. I would like to lecture on the underlying ideas of calculus. What is the traditional view or perception of our students on calculus? When I ask students, what do you understand by calculus? That is, what is differential calculus or integral calculus? Usually, I don't get any answer. The students or graduates, they don't have any clear perception, clear idea about the differential or integral calculus, which is the most important, I would say, the part of mathematics. And usually they answer, we can solve any problems, whether differentiate or evaluate integrals, we can do it. So usually in differentiation, we know any given any smooth function y equal to f of x, and we have to find out its derivative, okay, that is f prime of x, okay, or we say dy by dx, that is, which is called derivative. That is, using formulas of differential calculus and equations, we can find the derivative, or we can differentiate any mathematical smooth function, continuous function. And again, for integration, again, given any smooth differentiable function, and in that case we can evaluate the integral of, suppose, f of x dx. Yes, and using, again, we will use formulas existing of integral calculus, and we can evaluate this integration, okay. But the most important part of calculus, which is in fact mastering the underlying ideas of calculus, is missing. So this is a great concern for me, and also for science, or for future of our science, if this most important crucial part of calculus is missing. Okay, what we understand by calculus? Okay, what is it? This is in fact mathematics of change. Okay, mathematics of change, that describes changes in one variable, how it relates to changes in another variable. Okay, that is relationship between changes of two variables or among variables. In almost every human activity, we encounter two types of variables. Yes, one is controlled variable, another is uncontrolled variable. And by understanding quantitatively the uh, the dependence of uncontrolled variable to control variable, we can predict the uncontrolled variable. Yes, and suppose we can predict the environment, okay, which is in fact uncontrolled, but we have some control variable acting on which we can predict our environment. Okay, we live in a changing world where everything every time changes, and If we people with higher education don't understand the relationship between changes, how we'll make then optimum decision and develop ourselves? Even to survive, we have to understand the relationship between changes. For example, uh, if we take suppose acceleration of a car, which is in fact a velocity of changing rates, okay, to gas flow to engine, okay, that is how acceleration of a car uh, reflects on gas flow to engine, or inflation rate to money supply, or uh, nowadays the hot issue is COVID-19 infection rate over time, or suppose GDP growth rate, which is in fact the economic development of an economy. Everywhere we can see the most important underlying ideas is rate of change. Now, the rate of change, okay, we can see the underlying ideas, rate of change. Now, what is rate of change? Now, if we see uh, what is our differentiation, that is, differentiation is in fact this is process of finding derivatives. Okay, process of finding derivatives, finding derivatives. And what is our derivatives? Derivatives is the in fact rate of change. This derivatives is mathematical term, okay, and rate of change is physical term, okay, physical theme of uh, derivatives. So when given y equal to given y equal to f of x, any smooth function, uh, let's see of this x y, suppose at any point x, if we x if we want to find a tangent lines, okay, our function f of x, okay, and this is tangent line, and we can see this is change of x, and this one will be change of y, okay. In that case, the slope at this point x is called a derivative, that is y prime equal to f of x equal to dy by dx, which is mathematically that is defined by this limiting concept delta y by delta x. This is called derivative, okay. And in fact this is, we can see slopes of the tangent line. In fact this is in fact okay, slope of the tangent line, we can see The mathematical derivative concept, it has its physical theme, okay, which is rate of change, and it has its geometrical theme, which is slope, which is slope. Slope is the geometrical theme of derivative. So we understand that one mathematical concept, it has its different meaning, different underlines, underlying concept or thoughts. So now we'll see the what was the roots of calculus. Roots of